All right, let's take a look at this lesson. So we're going to be working on solving exponential and logarithmic equations. With some of them, we'll be using a calculator. So let's take a look at first of all, what does it mean to solve? To solve the, equation or exponential equation, what it means is we want to find out what x equals. That's what we want to do. Solving is find out what x equals. Okay, great. Perhaps you remember our work on transforming back and forth into logs and to exponentials. So those are very handy for many reasons. This is one. So we want to find out what x is, but if you notice, x is way up here as an exponent. How in the world are we going to find out what x is when it's an exponent? I mean, it's an exponential equation. What we would hope is that we could make the bases the same. But there's really no way to make 56 a base 5. That's just really not very practical. So we've got to approach it a different way. So what we'll do is we will transform the exponential into a logarithm. That'll get the x out of the exponent. So we talked about the circle-y thing. I don't know what else to call it. So if you recall, we want to do this. So the base of the exponential is the base of the logarithm. So we would say log base 5 of 56 equals x. And so that's what x is. If we wanted to put this number in a calculator, log base 5 of 56, we'd just get some weird decimal number, and that's fine. But there's no need to. We can just leave it like that. X is log base 5 of 56. Certainly if there was a way to simplify it, we would. But if there was a way to simplify it, we would have found it at the first step. We could, if 56 was able to be made a base 5, which it's not. So that would be our answer. I know it looks weird, but that's the answer. Okay, so let's look at number 2. Same scenario. We want to get to understand, or we want to find out what this x represents or what it equals. And so it's in the exponent. So we're going to use the same procedure. We're going to take that base, the e is a base e. We're going to take that and we're going to turn it into a logarithm. All right, so do we remember what the logarithm looks like that's base e? Okay, yep, it's the ln. ln of 124 equals 3x. Now, some of my students really want to put this e down here to show that it's base e, and you can certainly do that if you want to. It's not necessary because it's implied, but if it helps you, yeah, put it down there. So we're still focusing on solving for x. So what do we have? What do we need to do? Let's see. So we have a 3 here, and it's a multiplier, so we would want to divide both sides by 3 so that we can solve for x. So x is going to be 1/3 natural log of 124. So, which is good. This is the answer. It's going to be, again, some weird decimal number. Do we recall from previous lessons, what might we do with the 1/3? Is there a log rule that we could use that we could rewrite this in a different way? Yeah, there is, isn't there? So what we could do is we could pull that 1/3 up into the argument. So I'll just remind you, this is called the argument. Okay, so we could also write it as x equals natural log of 124 to the 1/3. And both of these answers are acceptable. Okay. All right. So let's take a look at number 3. When we look at this one, it looks different than the other ones. I want us to make a note here. So when we are working through these problems, what we want to do is we have to be sure before we convert. So before I turn an exponential into a log or a log into an exponential, it has to be all by itself. All right, so let's make that note. So before we transform logs or exponentials into their, the other ones, either log or exponential. The log slash exponential must be by itself. By itself. Okay. So that's a note. Let's highlight some parts of it. So before we transform our logs or exponentials, they have to be by themselves. If you notice on number 1 and 2, they're already by themselves. This 5 to the x is already by itself. E to the 3x already by itself. Well, let's look at number 3. This is the exponential part. And it is not by itself. We've got a 1/3 over there. We've got a 1 over there. And what we have to do before we can turn it into a log is we have to get it all by itself. So what would we move first? Would we move the 1 first or the 1/3? Yes, we would move the 1 first. So I have 1/3. I've got the 6, the negative 4x. I subtract 1 from both sides and I have 5. Okay, great. So now how do we get rid of the 1/3? Yep, I'm going to have to multiply both sides by 3. Now, I have had students suggest that I multiply the 1/3 times the 6, but that is not possible. Okay, let's think about why that's not possible. According to order of operations, I have to do exponents before I do multiplying. Since I don't even know what the exponent is, because it's got an x in it, how in the world would I do this exponent to the 6 before I multiplied 1/3 by 6? I can't. So I cannot multiply 1/3 in there to the 6. It's just not a thing. It would violate order of operations. So instead, I'm going to multiply both sides by 3 so I can move that 1/3 over. So I would have 6 to the negative 4x equals 15. Okay, so now we are at the place where we already were in numbers 1 and 2. I have, the exponential isolated. So now we're going to turn it into a logarithm. So log base 6 of 15 is negative 4x. So I divide both sides by negative 4, and I get log is negative 1/4. X is negative 1/4 log base 6 of 15. If I wanted to, I totally could pull this negative 1/4 up into the exponent, but I am happy just leaving it like it is. Whew, okay. All right, let's look at number 4. And we have the same scenario here. It's the natural log is not by itself. Here's the natural log part. It's not by itself. We have to get it by itself. So we want to divide both sides by 15. So we have ln of 8x equals 38 over 15. Okay, great. So now it's by itself. So let's do our conversion. Okay, let's put a little e down here. We'll just draw the circles. So e to the 38/15 is 8x. So let's rewrite it. So e to the 38/15 equals 8x. Almost there. We almost know what x is, so we divide both sides by 8. We get x is 1/8 e to the 38/15. All right. Fantastic. Okay, so let's go to the second page. Now we're going to work on solving logs. So the first one, let's kind of review a little bit from a previous lesson. So let me flip back there for just a moment. We'll look at a previous lesson. So I want to remind us, when we're solving logarithms, what is it that we're looking for? What are the ways we can solve logarithms? Okay, so here's some examples. Number 8, if I condense both sides and I get 1 log equal to 1 log, I can ignore the logs and set the arguments equal to each other. Great. If I have logs equal to a number, I can condense the log side and then do my circly thing. Okay, so those are our 2 options for solving logarithms. So let's go back to our lesson and let's look at the problems that we're faced with. So we've got, we have a log on one side. It's not by itself, so we need to move stuff. So let's move the 13. So I would subtract 13 from both sides. That gives me negative log base 10 of x equals, let's see, 17 minus 13, that's 4. Now it's still not by itself. I need to get rid of that negative 1. So divide both sides by negative 1, and I get log base 10 of x is negative 4. Okay, great. So we need the x out of here all by itself. So let's do our conversion. So we have 10 to the negative 4th equals x. Okay, great. This is our answer, but what if we didn't want a negative exponent? What if we wanted a positive exponent? Do we remember how to change that? Yep, that's right. What we would do is we would make that a fraction. So it would be 1 over 10 to the 4th. So either one of these would work. If the instructions say no negative exponents, then we would need to write it like this. All right, yay. Okay. Number 6, all right, now I have 2 logarithms. I can't convert to exponentials with 2, so let's bring them together. Okay, do we remember when we are adding logarithms what our conversion is? To condense it. Yep, adding is multiplication, so we're going to bring that together to be log base 5 of x plus 4 times x plus 1 equals 2. Okay. So now that the log is all by itself, we can convert it. Let's remind ourselves how to do that. So 5 to the second. So 5 to the second is this. Okay, so we have 5 squared equals x plus 4 times x plus 1. All right, so I hope we remember how to solve these back from our quadratics unit. I want to FOIL. So I have 25 equals x squared plus, let's see, 1x plus 4x is 5x. 4 times 1 is 4. So we can't solve it like that. We need to get it equal to 0. So we would have x squared plus 5x minus 21 is 0. So let's kind of think back. How do we solve quadratics? We learned several techniques. We could factor, using the bubbles to factor. That's not factorable. Okay. We could do quadratic formula. We could complete the square. But today what we're going to do is we're going to use our calculator to solve that. Okay, so let's move over to our calculator and let's do some calculator work. So the first thing that I want to do is talk about how we need to have our calculator set. So we need our calculator to give us at least 3 or 4 decimal places, because that's what we like to have in math. We're preparing for pre-cal and calculus, and we want to be able to have our calculator to, at least 3 or 4 decimals. If it's set at float, it's just going to do whatever it feels like. I'm just saying, we don't want to allow it to float. So what we want to do, we have 2 places to change it. So if you go to the home button and go to your settings, you'll see we have document settings right here. Okay, so you want to go into document settings. Here, these display digits. Okay, the display digits, see how we have so many options? We need to set it at least fixed 4. Fixed 3 or 4. We're going to go with fixed 4. And we're going to say OK. Okay, So there's the settings. We do that on the home screen. Now we also want to go to the menu. Okay, so let's go open a document. All right, let's do a new document. Okay, so let's not do that. Okay, so we're going to add a graph in. And now we're going to go to menu. And we're going to go to settings. Okay, so for our graphs, we want our display digits to be fixed 4. So again, we went to menu and settings. And so it is, I had already set it, so it's set on fixed 4. And so great, we're going to go ahead and OK that. If it lets me, it's acting crazy. Believe that? Okay. Okay, great. All right, so let's go to our tab key. And what we're going to do is we're going to, if it stopped acting crazy, we're going to type in our equations. So x squared, and it was, what was it, plus 5x, and it was minus 21. Okay, and enter. So there's our graph. Great. So we want to know when x is 0. So we've got 2 places right here. So here and here. We want to find the zeros. So the way we do that is we go to the menu, we go to Analyze Graph, and we find our zeros. Great. So let's go over here. Let's get this one first. So let's highlight the one we want. Okay, negative 7.7202. Great. Let's go to the menu and get our second one. Again, we're going to Analyze Graph. And then we're going to number 1, which is 0. And here we go. So let's highlight that. All right, we have our 2 answers. Wonderful. So let's go back to our problem and check that out. So what it says is, it says that x could be either 2.720 or x could be negative 7.720. All right, so let's check that out. Where do we need to check that out? You remember? Yeah, we need to go up here. We need to go into each argument and try those numbers out. If either of those numbers turns either argument to negative or 0, we need to cross it out because that would be imaginary. So would the 2.72 work in both arguments? Yeah, that would still be positive. We're okay there. What about the negative 7.720? Yep, you're right. That will not work. So we cross that out. So what we're doing is we're showing that it was a possibility. We researched it, and it's not going to work because it causes imaginary numbers. And we just have one answer. All right, great. One more problem. So here we are starting to work on applications. And so let me give you the formula that we're going to use for this. A equals PE to the RT. All right, so I'm not going to have you memorize these. I will give them to you, but I'm not going to tell you what all those things stand for. You have to know that. And you need to know when to use which formula. So let's start analyzing. What is this? So this number is our beginning value. That's the beginning value of whatever, it's money. This is about compounding continuously, so it's money. It's the beginning money. Okay. This R is the rate, and it has to be in decimal. Okay. And then this T means time. That's time. And it's annual in this case for compounding continuously. All right, so let's make a note here. So if we see these words, let the computer catch up with me. If we see these words right here, that means that we need to use this formula. This is the formula that we use when we see the words compounded continuously. All right, great. So let's figure out what to plug in. So let's write our formula right here. A equals PE to the RT. And A, by the way, means the final amount of money. That's the answer, the final amount of money. Now, we want to see how long will it take for an investment to triple. They didn't give us a beginning value. But whatever money we have, we want it to triple. So why don't we make it easy on ourselves? And let's just say we have $1, just $1. And if we want the dollar to triple, then that would become $3, right? That's what it would be. We'd have $1, then we'd have $3. E is just that 2.7 number, you know that. R, well, the rate is right here. Is that a decimal? Okay, that's tricky, right? It does have a decimal in it, but is it in decimal form? And the answer to that question is no, it's in percent form. So we need to remember back to our middle school years or elementary years, whenever you dealt with, probably elementary, decimals, percents, fractions. Remember, we have to go over 2 spaces. So our rate would be 0.085.